In our lesson today, we're going to look at something called the pH scale. So what is that? Well, the pH scale measures and compares the number of hydronium ions, H3O+, to the number of hydroxide or OH ions in a solution. So what I'm saying here is every time we have a solution, we have both the basic molecule present and the acidic molecule present. Well, how is that possible to have both of these acidic and basic molecules present in a solution? Well, let's think about this. If we take the hydronium ion and we add it to the hydroxide ion, and we just do a little maneuvering around here, let's take one of those hydrogens, stick it over there. What do you make? With this double arrow, we technically are going to make two H2Os. So what this is saying is that every time we have water, it's going to break down and make these two molecules, and then these two molecules are going to find each other and they're going to make water, and it's just going to cycle along here. So every time you have water present, what I'm saying is you have a certain quantity of hydronium and hydroxide ions present. Before we move on here, just want to point out something. You ever notice the pH scale title up here? It's a small p and then this capital H. Well, what this capital H is really standing for is it's really standing for this H3O+. It does say the pH scale is measuring and comparing hydronium ions. So technically a way to write this would have been the PH3O+ scale. Of course, that doesn't look very good. But the pH scale, the bottom line here, is all about these hydronium ions. Okay, so what is this pH scale all about? Well, it's got some key numbers here, 0, 7, and 14. But not only does it have these numbers, it also has every number in between. Now, on any number that ends up on our scale below 7 is going to be an acidic solution. And I've got this gigantic A here. And what this A is standing for is it's standing for the most concentrated acids fall at with the lowest numbers. And then the least concentrated acids are falling closer to 7. So again, anything less than 7 is acidic. Words some people get confused is they start using the words strong and weak. You'll see it in textbooks. They'll say strong acids have pHs lower in the scale, and that might be true, but the strong part is not referring to its pH, it's referring to its degree of ionization. You can have a weak acid that has a really high pH, or a really low pH, close to 0. That's possible, and vice versa. Just by taking a strong one and diluting it, you can, of course, raise the pH to 7. So don't get caught up with those words. Anyway, so there's acidic. And what we're doing here is we're comparing the hydroniums to hydroxides. So when it's acidic, we've got a greater quantity of these hydroxide molecules. So what happens when we're above 7? Well, we end up with the basic range. Again, we have these two molecules present, but now this time we're saying that we have more of the hydroxide ions present. And when you have an equal number, you get a neutral solution. So where do the numbers on the pH scale come from? They come from something called logarithms. This is sort of a complicated math thing. You don't really need to understand how they work. I'm going to explain it here. You just need to be able to use a log on your calculator. And I'm sure you've seen this button on your calculator before, called the log button. That's the one we're going to need here. So if you grab your calculator right now, I want you to try something. I want you to type log 10 and hit the equal sign. Now it depends on your calculator. Sometimes you might have to type 10 and then hit the log button, or sometimes you can just type log of 10. But if you do this properly, you should get the answer of 1. So that's our first experiment here. Now I want you to try and figure out what the log of 100 is. And if you type that in, you'll find you get the answer 2. Let's try this one more time. What's the log of 1,000? You get 3. So it's not necessarily the number of zeros. What's going on here, and again, this is where it might be a little complicated, is what we're saying is that we want to take the number 10 and rearrange it to have a base of 10, and then the exponent is actually going to be our answer. Probably makes a little more sense with the second one. So 100 is also equal to 10 squared. So that means the log of 100 would be 2. And lastly, 1,000 is equal to 10 to the power of 3. So the log of 1,000 would be 3. Again, it's not integral, you understand that, but we will need the log button here as we get into this stuff. So it's all based on the power of 10. We've gone up times 10 each time, and this is what our scale is based on. So if we jump back to this and we take a look down here at the end of the scale, if we have a solution with a pH of 14 and we're going in the direction of 13 here. What we're doing is we're actually getting 10 times more concentrated for this hydronium ion. This all depends on which direction you're moving on the scale here. But as we go down here, the numbers get lower. What we're doing is we are increasing each time times 10 the hydronium concentration. And it's just getting stronger and stronger and stronger and stronger and stronger and stronger until we're essentially off the scale here. So our quantities, if you're comparing something 14 to 0, well, we just have to times 10 times 10, all these multiplied by tens, and that's so much stronger your solution will be. So this is where our formula comes in. Simply to calculate the pH of something, because all these times 10, what we're going to need is we're going to need the negative button on our calculator, the log button, and we need to know the concentration of the acid or the hydroxide concentration. And you'll see this also written like this. It might just be H+. They mean the exact same thing. Probably in textbooks, it's more common to see this one than this one, but the H3O hydronium is more correct. So let's see how this works. So let's determine the pH of a solution of an acid, HCl, with a concentration of 0.075 molar. Again, that's moles per liter. So all we need is our log formula. And we know our concentration. Our concentration is that value, so we're going to plug it in here. Let's jump over to the calculator, and I'm going to show you how to calculate this now. So once you've figured out how your calculator works, for this one on Google, I need to just type negative and then log, and then our answer 0.75. And there we go. So we'll round that number and continue on here. So as you can see, we've arrived at the answer of 0.125. So where does this put us on our scale? This should put us it's just above 0 here. So this is extremely dangerous, this solution. It is very acidic. Let's try another problem here. Let's determine the pH of a solution when 3 grams of NaOH are dissolved in 100 mils of water. This one's a little different. We don't know the concentration off the bat. So we're going to have to do a little calculation. So C equals N and V. So what do we know here? We know our volume is, well, it's not exactly 100 milliliters. It's 0.1 liters. Don't forget we're working in liters. And this 3 grams is nothing right now. What we can do is we can turn it into moles, though. So let's find the moles of sodium hydroxide. Let's write our 3 grams of sodium hydroxide. And to the old boxed expression, we're going to have 1 mole over 40 grams of NaOH. Cancel out the grams of NaOH. Becomes 3 divided by 40. And we get an answer of 0.75. So let's write that in for our moles. And now we're just about ready to do our concentration. So there's our formula, C equals N over V. Plug our 2 values in, and we get a concentration of 0.75 molar. And now we are ready finally to find the pH, because now we have a concentration. So we'll write our formula. We'll put our 0.75 in. I'm not going to cut to the calculator now because this is actually the same number we had before. So our answer is the same. Or is it? Let's see here. So this answer would put us right here. Now just to prove this is the same, I'm just going to flash back to that previous question. There it is. It's the exact same values, the exact same answer. But how could it be the same answer? This problem was about hydrochloric acid. The problem we're doing is about NaOH. Does this answer here make any sense? Could our basic solution have a pH of just above 0? Answer is it cannot have it. Something weird is going on here. This is the point in the lesson where I turn to the class and I say, well, if this answer doesn't make sense, can anybody guess what answer might make a little more sense? And usually one person in the class will say, well, shouldn't our answer be closer to the end of the scale? Shouldn't it be right near 14? Because this base is very concentrated. We're finding concentrated bases down at this end. And I say, yeah, that's exactly it. And so exactly what do you think it is? Just take a crack here. And usually someone will say, well, it's probably just what we're going to do is we're going to take 14 and we're going to subtract our answer. And that is exactly correct. So the pH of the solution is in fact very close to 14. It is a very concentrated solution. We've actually made a bit of a discovery here. We've made a discovery about the opposite of the pH scale, which is the POH scale. This is like a bizarro pH scale. Let's investigate this here for a second. Everything on the POH scale is flipped around from the pH scale. So we still have these same numbers, but what's going on now is we now have bases falling in this range because from 0 to 7, we get more of the basic molecules. Our acids are now above 7 up to 14. This is the area where we have more of the hydroniums, and then the same thing, we still have neutral happening in the middle. So if you think about our last answer of 0.75 on the POH scale, that would make perfect sense because it would be a very strong base and it would just be a very concentrated base and it would just be above 0. So our answer made sense on the POH scale. So that's what we actually found in the last problem, the POH of the question. So we've got some issues to address here. Now don't get too confused. At the end of this video, I'm going to do a summary and I'm going to put this into perspective. And doing the first couple of homework problems are going to make this seem quite easy. So there is our formula. And what we did was, if you add the two values together, you're always going to add them up to 14. And that's why we were able to subtract in that previous question. Really what we did was we took 14 and we subtracted POH to get our answer of 13.875 or whatever it was. So what we've done here is, the first type of question was, if you want to determine the pH, you must have or calculate a concentration. Once you have that concentration, you can use your pH formula. So remember, there are two ways we can find concentration. C equals N over V, or flip side here, you could do the dilution formula. So just be aware there are two ways, depends on the question. So concentration at pH is that formula. So make sure you write this down. You're going to use this basically all the time here, no pun intended. Well, what happens if I give this, what happens if I reverse the question? What if I give you a pH and I want to know a concentration? Well, we're going to have to rearrange our formula. So to determine the concentration of an unknown solution from a known pH, and this is, by the way, the easier of the two, you have to rearrange the formula. It's not just a simple rearranging, but it's maybe the easiest formula you're going to come across here. So if you want to figure out the concentration of a solution, by the way, square brackets actually means concentration. So if you want to figure that out, all we're going to do is we're going to take 10 and we're going to raise it to the exponent of negative pH. I'll show you this on a calculator here in a second. So let's try a problem out. They're all kind of the same. Determine the concentration of a solution of nitric acid with a pH of 7. By the way, these values correspond. It's nitric acid, I'm asking for pH, and I've given you a value in that range. If you get a question where something doesn't match up, like say I gave you nitric, but it was the POH and then this value was wrong, you'd actually need to do that subtracting trick. So sometimes in these questions, you need to subtract at the end, and other times you need to subtract at the start. It all depends on what I'm asking. But let's proceed with this question, and then we'll come back and investigate this idea a little bit more. So pH to concentration, there's your formula. There's what we're going to do. Let's cut to the calculator and see how it's done. So with this one, we're going to use a different button than before. We're going to enter 10, and we're going to use this X to the Y button, and then negative 2.5, and that should give us our answer. So again, you need to know how your calculator works. Sometimes what you need to do is you got to figure out when to put that negative in. Hopefully it's just as simple as type it in as it appears. And now that you have your value, you get there's your answer, and this is, you need a unit on this one. pH is unitless, no units on 2.5, but definitely a unit on the concentration. It is measured in big M or moles per liter. Let's look at a summary here. So summary, if you're talking about the pH scale, you're going to be using the pH formula here with the negative log, or the reverse of this is the 10 to the negative pH. If we're talking about something on the POH, what you're doing is you are taking the negative log of the base, the hydroxide. And actually, I didn't talk about this formula, but it's exactly the same. And we tie these two formulas together using this one at the bottom here that we did use in that example problem. Now, if you were clever and can think about rationalizing questions, you don't ever really need to use these two formulas. You can only say, and mostly you're just using these two right here. These two kind of go together. So if a question is, I want you to find the pH and it's an acid, then your answer is fine. If I want you to find the pH of something and it's a base, then you're going to have to do some subtraction. The flip side could be if the same thing would be true if I gave you a POH of something and it was an acid. The two wouldn't match up. You need to do some subtracting. So when things don't match up, when OH and H plus or pH or things like that aren't going together, then you need to subtract. Now it's important we take a look at the homework, especially the first couple of questions. And so check out the next video, and we're going to look at that idea a little bit more, and I think it'll become a lot more clear at that time.